Hi, and welcome in episode 3 of Johnny Does .NET. My name is Johnny Hooibergs, and in this series of videos I will tell you a little bit more about my favorite programming platform, .NET. In this episode, I will discuss about the differences between the .NET Framework, .NET Core, and .NET. In my previous video, I already told a little bit about the differences between .NET Framework and .NET Core, but now I can go into much more detail. As I said before, .NET Framework, obviously, the older version of the .NET platform, .NET Framework, was only restricted to Windows. So you can only create Windows-specific applications by using the .NET Framework, which is logical. Microsoft has built and released the .NET Framework in 2002, and in this time, the entire purpose of .NET was just to be available on Windows. Now in 2016, when Microsoft created a new platform, .NET Core and .NET Today, they started from scratch and they could just do everything from the beginning. And they were looking into the future and they said, okay, we should really build a platform, a popular platform that is really platform independent. And that is what .NET does. So this is already a huge difference between the .NET Framework and .NET Core or .NET. So where .NET Framework is restricted to Windows and .NET Core and .NET is really platform independent. But of course, because the .NET Framework is already 20 years old and it is specific to Windows, it is also backwards compatible with all of your older applications. If you have even more older applications, and before the time of .NET, before 2002, your .NET Framework applications can still be compatible with those applications. They can still communicate by using older technologies, but the .NET Framework is not dead yet. It is still supported by Microsoft, so it can still provide you with that backwards compatible thing. .NET Core, on the other hand, and .NET, of course, is future-proof. Again, Microsoft decided to build it from scratch, start all over, really with the future in mind, and it is future-proof because of that. It is platform independent. It doesn't really matter if it runs on your local PC or in the cloud, because, of course, today applications all tend to be web-based applications or cloud-based application, and because .NET Core really supports this from the get-go, it is really future-proof. Also, very obviously, because the .NET Framework came out in 2002 and was very specific to Windows, it also has better Windows integration, which is logical. .NET Core, however, because it's platform independent, has a little less Windows integration because some things in Windows don't make sense on other operating systems. Actually, a pretty good example of that is the registry in Windows, and I'm actually trying to find the registry as an example here. This is the registry editor in Windows. This is used to edit the registry. That's why it's called the registry editor. And the registry in Windows is just a key value database that has many configuration values for your operating system. It's very important in Windows. It's heavily used in Windows, but it only exists in Windows. So in the .NET Framework, where you are backwards compatible and you have very good support for the Windows operating system, obviously you have namespaces and classes and methods that you can use to interact with the registry in Windows. You can read registry keys, you can write registry keys, you can create and delete registry keys, because it is a part of Windows. On .NET Core, by default, this is not available because the registry does not make sense on Linux or Mac, because the registry does not exist on Linux and Mac. And because .NET and .NET Core are really platform independent, they should only implement the features that are similar on all of these platforms. And that's why the registry is a good example of something that is very specific to Windows. And if you need to interact with the registry, you should use .NET Framework. However, The .NET Core also supports external libraries. So you and me as a developer, but also Microsoft, they can build additional libraries next to the framework itself, next to the framework class libraries and the base class libraries, to extend what a platform can actually do. And the registry is also part of an external library that you can actually add to .NET Core. So you will still have the option to use the registry in .NET Core. But of course, when you do that, you lose your platform independentness. You cannot use the registry on a Linux environment, for example. So it does not really make sense. So if you are really trying to make platform independent applications, keep that in mind, and keep in mind that you can only use things that are really platform independent. If you need Windows integration, you can still choose between the .NET Framework and .NET Core. The .NET Framework has built-in Windows integration, and in .NET Core you will have to do some figuring out to see if there are external libraries available that can help you reach this specific use cases for Windows only. And yeah, with this, the .NET Framework is actually the way to go for your legacy applications. If you have applications that are already 15 or even 20 years old, just like the .NET Framework, you can just keep on using the .NET Framework. There's no harm. The .NET Framework will still be supported for some time. There is no end date known yet. Microsoft still invests in the .NET Framework because so many larger applications are existing out there. So they should keep supporting them. Of course, when you have already a kind of an old application, but it's very, very small and it doesn't really take a lot of time to create a newer version in .NET Core, for example, you can go ahead and recreate your application in .NET Core. If it's only a couple of hours or even a couple of days work, you can go ahead and you can migrate from .NET Framework to .NET Core. But if it's a larger application that needs weeks or months or even years to completely convert to this real platform independent .NET platform, that's probably going to be a little bit more difficult, and you will most likely come up with some situations or run into some situations where stuff doesn't work like you would expect it to be. So in that case, again, it's you can just keep it in the .NET Framework. It is still the way to go for your legacy applications. But then obviously, when you're creating a new application from scratch, something completely new, you shouldn't really look into the .NET Framework then. You can just go for .NET Core. You can do almost everything in .NET Core what you could do in .NET Framework, but now you have the future to look into, and you can build your applications more performant with a more lightweight platform like .NET, and maybe in the future you can even run it on other operating systems if you want to. So yeah, again, .NET Framework is the way to go for your legacy applications if they are too large to migrate to .NET Core, or if they just don't need to be migrated because .NET Framework is still supported. And .NET Core is for all of your new applications and your platform independent needs. Now, if we look at this, you hear me talk about .NET Core and .NET, and I mix and match in between those two terms. There's actually three platforms, as I explained in my previous video. There's like .NET Framework, .NET Core, and .NET. But because .NET is actually just the rename of .NET Core, those are basically the same thing. So there's only two. You have .NET Framework, the older one, the one that came out in 2002, and then there's .NET or .NET Core. I will use those two terms and I will mix and match. But .NET Core and .NET, they came out in 2016 and they are the new platform. So there's only those two choices for you. And hopefully in the future, 5 years from now, 10 years from now, who knows, we'll only have the new .NET platform and we can forget about the .NET Framework. We'll see what happens. If we look into .NET and .NET Core, so not into .NET Framework, but only .NET and .NET Core, we can see that it's really a platform-independent framework. It does not only run on Windows, it also runs on other operating systems. More specifically, it also runs on Linux and Mac. So we have 3 operating systems we can build applications for. It runs on Windows, it runs on Linux, and it runs on Mac. It actually also runs on mobile devices with Android or iOS, but we will talk about that a little bit later. But next to that, it also supports multiple processor architectures. It supports the ones that we know from our PCs, like the x86 and x64 from AMD or Intel, those kind of CPUs, which is the same as the .NET Framework. The .NET Framework also runs on those two. But in addition, .NET also runs on the ARM architecture, and the ARM 32-bit or ARM 64-bit, which I'm very thankful for, because in the bottom, for example, you can see IoT. IoT are these smaller devices that don't have a screen, embedded devices, mostly just a print board or a motherboard, or a little motherboard, like the Raspberry Pi, for example. I'm using that in my home just to play around with very often. And it's cool that I can create a .NET application and I can run that on a Raspberry Pi running a Linux distribution. For example, I'm running .NET applications on a Raspberry Pi, running the Raspbian Linux distribution, which altogether runs on the ARM64 processor architecture that is inside of my Raspberry Pi. And it works perfectly fine, very performant, very cool that with .NET we really have this platform independent thing going on. And of course it also runs in cloud environments. Whatever you want to do in cloud, there is support for that. And if you want to do containerization in Docker, for example, it will also work great. But I will talk about those things in more details later. Now, with that, I can maybe show you a little bit of code to show you these differences between the .NET Framework and .NET Core. So I'm just going to very quickly find me an instance of Visual Studio. So just give me some time. Let's open the Visual Studio like this. So Visual Studio is the application that we as a developer can use to create applications. A little bit weird, but it's like an all integrated tool, an integrated development environment where we can create our applications, and this environment will help us doing that, so that we don't just need to write code without any help. This tool will really help us to do that. When you want to create a new application, you basically create a new project that contains all of your source files, and then those source files will be compiled by the C# compiler into .NET Intermediate language code that then by the runtime will be run, interpreted, and then compiled to machine code just in time. So I will do that. And there's different kinds of .NET applications, different kinds of templates we can use to create these different kinds of .NET applications. In one of my following videos, I will discuss all of these, or at least most of these templates in much more detail. But today, just as an example, I'm going to create a console application. If you're trying to find a console application in this whole list of templates, you can just use the search box in the top to find console applications. And you can immediately see that there's two different kinds of console applications. There's console app, just that, and then there's console app .NET Framework. So in here you can already see the distinction between a console app in the .NET Framework and a console app in just .NET or .NET Core. So yeah, maybe we'll start with the older .NET Framework. So I will select the console app specifically for .NET Framework. I'll click next a couple of times. It doesn't really matter what the name of my project is going to be. It's just to show you what it looks like. But I can show you, however, that you are able to select the version of the .NET Framework you want to use. There's actually versions here that are not supported anymore, but I'm just going to pick the latest .NET Framework, which is 4.8. And remember, 4.8 will be the last version of .NET Framework ever. So no new versions in the .NET Framework, only in .NET itself. So I'm just creating this, and I have to wait a little bit for Visual Studio to create all of the files on my file system and to load the project into its user interface. So let's be patient for a little bit. There we go. And this is a console application, or an application that runs in the console or in the terminal. This is .NET Framework, so it's not platform independent. It has a main method that will execute our C# code. What am I going to do? nothing very important really. Let's just do console.writeLine. So I'm just going to write a piece of text to the console, and that piece of text is going to tell me hello. And I'm going to do it in English. And then, just to make things easy, I'm going to do a read key in the end so that my application does not shut down immediately after printing hello. Because, yeah, your application basically runs from here to here, and when it reaches the end, it immediately shuts down. So I'm going to wait for a key that's being hit on the keyboard so that at least I can see that my application is still running. So I'm going to start, and when you click start in Visual Studio, it will compile your application to intermediate language. It will then run the .NET Framework runtime, and that will interpret your compiled intermediate language into machine code just in time, and so on. All the cool stuff that I talked about in my previous video. So let's start. Again, be a little bit patient. And then here is my console window telling me hello. And I can touch whatever key I want, but I'm always inclined to touch the enter key. It doesn't really matter, but there we go. That was my enter key, and my application stopped running. Now, what I want to show you is that when I display the file structure of the files that are being created on my disk, I can see that this project has a bin, a binary directory, and within this binary directory is the name of the configuration that I'm running. I'm running in debug because I'm a developer. I want to see if my application runs correctly. So the debug configuration, and this has an executable file and then some configuration file, and then a program debug database file. So I'm just going to ignore the bottom two files. I'm just going to look at the executable. This is my application. I have a running executable. I can give this to somebody, and that person can just double click the executable, and it will open a console that says hello until he presses the spacebar, for example. Perfect. So as you can see, there's an executable. You probably know in Windows an executable file is an application that you can run. But actually a lot more things are going on right here, because this executable is a .NET Framework executable. It's not a real executable. It's not a native executable. In normal cases, an executable contains machine code, compiled machine code. But as I told you before, .NET works with its runtime. So this executable is kind of a fake executable. It contains intermediate language, and when you double click it, it has a very small part of code that will actually talk to the .NET Framework runtime. It will start the .NET Framework runtime, and then that runtime will read this executable or the intermediate language within this executable, and it will start just in time compiling that to machine code. So it's kind of a fake executable, but it still works. If you have the runtime installed on your machine, or the SDK in my case, by just double clicking that file, it will work perfectly fine. So this is what the .NET Framework looks like. Now, if I open a second instance of Visual Studio, and I create another console application, but this time a .NET console application. So console. Just be patient. There we go. There's the console app for .NET Framework, which we used before, and here's the console app for .NET. It doesn't say .NET, but you just have to know that console app is .NET, the latest and greatest version, and there's also one for .NET Framework, the older one. It's already .NET Framework has already has this thing like it's the old thing. You can still use it, but please don't, or at least it feels like that. So the console app, I press next. That doesn't really matter what name it has, and then it asks what version. And here it's the same thing as with the .NET Framework, but here there's only the supported versions. So there's .NET Core 3.1, which is actually still supported until the end of this year. There's .NET 5, which is the previous version of .NET, and then there's the current version, long-term support version of .NET, .NET 6. So I'm just going to pick the latest .NET, and I'm going to click Create. Same thing happens. Visual Studio will create all of the files for me, and it will open the project within its user interface. So I have to be a little bit patient. Now, the whole structure of this application in Visual Studio will be very similar. The C# code looks a little bit different, but I will talk about this in very much detail later, not in this video. But the structure of the project is pretty much the same thing. We have the solution in the top, we have the project, and then we have all the source files within that project. I'm just going to change the text to reflect the same thing as my .NET Framework application. So it says hello, and then not hello with the W in the end. That's weird, but just hello. And then console.read key, so that my application doesn't quit on me immediately. I can start it in pretty much the same way as a .NET Framework console app, and I get the console that says hello. Perfect. If I press a key, it will end. Already a little difference here. You can see that the console application doesn't shut down, or at least the console window doesn't shut down. The application shuts down. But the window is created by Visual Studio, and Visual Studio just tells me the application has ended. You can press any key to close this window also, which is already a little bit different than the .NET Framework template does. Now, if I do the same thing and I open the folder and I try to put these folders next to each other, and I also open the bin debug folder, again, a very small difference here. In .NET Framework, you just have bin debug, so you just have your binary files and then your configuration debug and then your actual binary files. In .NET Core, you have your bin debug and then the specific name of the platform you have compiled for. So in our case, .NET 6. Now, you can see that there's already a big difference here. In our .NET Framework application, we have a console app executable, but in our .NET application, we have console app DLL and an executable, which is weird. So here, there's actually two files being created, and if you want to give your application to somebody else to run it, he or she actually needs both of these files to be able to run your application. And the reason is very simple, because .NET is platform independent. An executable does not really make sense, because an executable like the .exe file here on Windows is only specific to Windows. It does not exist in Linux or Mac. They have different kinds of executable files. So this is very specific to Windows. And that is actually why your application or the intermediate language that's being compiled by the C# compiler is actually located inside of the DLL. Whereas for the .NET Framework, it is inside of the executable. Very important difference here. So the DLL is platform independent and can run on whatever platform you like, basically. A DLL, if you don't know a DLL, in Windows, a DLL is a part of an application, but you can actually split up your application in multiple files. You have your main executable, which is your main application, and then you can have as many supporting DLL files as you want. You can use it as a logical way of structuring your code. You can put a little bit of your code in one DLL, a little bit of your code in a second DLL, just to make it more neat and easier to understand for you as a developer, and then have a main executable that actually runs and loads all of these DLLs at runtime, and then it will actually have additional functionality based on those DLL files. It's also quite handy if you have a piece of code that you want to reuse by multiple of your applications, and you can create one DLL and then just copy paste that DLL in all of your applications without the need for you to write the code over and over again. But in this case, the .NET platform will use it to put all of your application code inside and not in the executable. The executable in this case is created because we are working on Windows right now. So Visual Studio will build the executable for us to be able to run our application, because we need an entry point. And in Windows, the entry point is the executable. So in this case, the executable is a binary executable. It contains machine code, but it contains machine code as a bootstrapper, and in that machine code will run the .NET runtime, and that runtime will then read the DLL file, read the intermediate language from that, and compile that just in time to machine code. Very cool. So if I double click the executable, the same thing happens. My console application opens and tells me hello. If I press a key, it disappears. But as I said before, the executable starts the .NET runtime, and the .NET runtime reads the DLL file. So if I remove the DLL file, my application will not work. I double click and I can see that it says the application to execute does not exist. Well, yeah, I just removed it. The DLL file is now gone, so my application does not work anymore. So yeah, a very, very, very important difference between the .NET Framework and .NET Core right here. Just to recap, on the left-hand side, the .NET Framework with the executable that is only available on Windows. It's a fake executable. It's also a bootstrapper that runs the .NET Framework runtime and then reads all of your application intermediate language from there and just in time compiles it to machine code. On the right-hand side, .NET 6 version of the same application, where it's really platform independent. It had the DLL file because I removed it, where your application is located, and then it has the executable bootstrapper that makes it able to run on Windows. Actually, in the first versions of .NET Core, the 1.0 version of .NET Core, in 2016, there was no executable. We were only getting the DLL, and we needed to call the .NET CLI, the .NET CLI tool, the command line interface tool, and then as a parameter we needed to provide our DLL that contains the application to actually run our application. But that's not very user friendly, so that's why by default the executable for the platform you're working on will be automatically generated, and you can use it just like that. Now, just to show you, I have prepared a Linux environment, actually Ubuntu Linux, where I can do exactly the same thing. As I told you, .NET is platform independent, so I can also run it on a Linux environment. So this is my Linux Ubuntu desktop. I can open a tool just like Microsoft Visual Studio. This is Visual Studio Code, which is a separate tool, but this is the platform independent version of Visual Studio. So Visual Studio is like a big application that helps you with all different kinds of things, but it's only available on Windows. You also have a more lightweight version, which is Visual Studio Code, which is available on multiple platforms. So now I'm using this on Linux. I am using its user interface to create, based on a template, a new .NET application. And actually, in the background, it's using the .NET CLI to do that. So .NET New is the .NET CLI to create a new project based on a template. The template I'm going to use is, of course, the same console app, but this is .NET and not .NET Framework, obviously, because I'm on Linux right now. So I'm building a .NET application on Linux, which is also platform independent. Visual Studio Code would like me to pick a folder to store my project. So I'm just going to create a new folder called tests. We're inside of this new test folder, and I'm going to choose this as my output directory. If I did that and I choose also test as the name of my project, the project gets loaded into Visual Studio Code, and I can see the code. It says console write line hello, so let's keep that. Hello, like that. And just also add the console.read key. Now, Visual Studio Code is a little bit different from Visual Studio. There's no play button in the top, or at least there is, but you need to do some additional steps. But I'm just going to use the terminal in the bottom. So I'm just going to use again the .NET CLI to run this application by calling .NET run. It will now compile my application, so by using the C# compiler into that executable and DLL file, it will then run it right here. So it says hello. I can press any key and I immediately exit out of my application. just like that. So it works perfectly. But now I'm on Linux. So if I look at my file system and I open my files, I go to source and then tests and then bin debug and .NET 6. By the way, exactly the same as on Windows. The structure of the files is exactly the same. I have the same folders, the same project, the same source code, and then it gets compiled into the same files. I also have the DLL file, I have the dependencies.json file, I have my program debug database file, but I have a different kind of executable file. This is actually the only difference here. This is not a .exe file, this is a Linux executable file. You can see it by the icon. It says it's like a cogwheel, so it's an executable file. You can also see in the properties on Linux and with the permission that this has the execute permission on enabled. So this file can be executed. And it's the same thing. The DLL is just a platform independent version of my application. It contains the intermediate language that gets interpreted by the .NET runtime and then just in time compiled to machine code, just the same as on Windows. But now the only thing different is that bootstrapper executable file. Of course, in Linux, I cannot just double click this, but I can open the console or the terminal to find this. So it's in the sources directory and then in the test directory, in the bin directory, debug directory, and then the .NET 6 directory. This is now the same as above. And so this is the visualization of that folder. And then here we have the console version of the same folder containing the same files. You can see that the test executable file is also green, which means it's executable. So I can just execute it by typing it like this. And now it runs my application on Linux, just as it would run on Windows. I can press any key to stop my application. I press the T key. That's why you can see the letter T in the beginning there. And that's it. Now I've created both the .NET Framework version and the .NET Core or .NET version of this simple console application. Very cool. One on Windows, one on Linux. And you can see that there are clear differences between the .NET Framework and .NET Core. And again, we reached the end of this episode where I talked about the differences between the .NET Framework, .NET Core, and .NET. In the next episode, I will talk about the .NET CLI or the .NET command line interface, but also other tools that can help you as a developer creating your applications like Visual Studio and Visual Studio Code. Did you like this video? Then give me a thumbs up. And if you like to be notified of my next videos, don't forget to subscribe, and I'll see you next week.